Sessions, access tokens, JWT, OAuth, OpenID Connect. Auth conversations often put those 5 labels in one menu, as if you click one and reject the others. That is why the architecture gets confusing. They describe different layers of the system. In this episode, we are going to separate those layers, rebuild the map, and end with a decision rule you can actually use. Start with 2 verbs. Authentication establishes identity. Who is making this request? Authorization evaluates authority. May that identity perform this action on this resource? Signing in can establish that I am steward. It does not automatically mean I may delete every account. Your auth system must carry identity to the server. Then your policy must turn identity plus context into a decision. Mixing those jobs creates permissions that are too broad and bugs that are hard to name. For a conventional first-party web app, the boring default is excellent, a server-side session. After login, the server creates a random session identifier and stores the account, expiry, and any useful state behind it. The browser receives only the opaque identifier in a secure, HTTP-only cookie. On each request, the cookie points back to central state. Logout can delete that state immediately. Role changes can take effect on the next lookup. The trade is that the server needs a session store, and every participating server needs access to it. This is state management, not a token format contest. The cookie still needs a threat model. HTTP only keeps ordinary client-side JavaScript from reading it. Secure limits it to encrypted transport. Same-site policy helps constrain when the browser attaches it across sites, and state-changing requests still need a deliberate cross-site request forgery defense. Rotate the session identifier after login, so an identifier planted before authentication cannot become the authenticated session. Store only an unpredictable reference in the browser. Set an idle and absolute expiry, and make the server reject a session whose account was disabled. The word session describes where state lives. These controls decide whether that boundary is safe. An access token solves a different problem. It is a credential a client presents to a resource server. Bearer this credential, receive this access. Because whoever holds it can usually use it, transport and storage matter. Give the token a narrow audience, short lifetime, and scopes that describe the smallest useful capability. A mobile app calling an API, or one service calling another, needs a portable credential across that boundary. Your own server component reading its own database usually does not. Tokens are for boundaries, not decoration. Now choose the credential format. An opaque access token is just an identifier. The API checks central state or asks the issuer what it means. A JWT is a compact, signed set of claims. The API can verify its signature, issuer, audience, and expiry locally, which is valuable when many services need independent verification. But local validation does not consult central state. Immediate revocation therefore needs extra state, very short lifetimes, or a rotation strategy. JWTs can be revoked. The point is that self-contained validation alone does not perform that check. You also inherit key distribution, key rotation, and careful claims validation. OAuth is an authorization framework. It lets a client obtain delegated access without receiving the user's password. That is why an app can ask for permission to read a calendar. OAuth by itself does not standardize your application login. OpenID Connect adds an identity layer on top. The provider authenticates the user and returns an ID token whose claims your client can validate. So, use OIDC when an external identity provider signs the user into your app. Use OAuth scopes to constrain delegated access. They often travel together, but they are not the same promise. The architecture becomes real at the lifecycle edges. How does logout work? With central sessions, delete a record. With self-contained access tokens, the already issued credential may remain valid until expiry unless you add revocation state. What happens when a signing key rotates? Verifiers need the new public key and a safe overlap window for the old one. What happens when a device is stolen? Refresh credentials need stronger storage and their own rotation and reuse defenses. The best design is not the one with the fanciest acronym. It is the one whose failure and recovery paths your team can operate. The decision should follow the attacker and the boundary. Browser cookies are automatically attached, so cross-site request forgery matters. Bearer tokens travel explicitly, so theft from logs, storage, or an overbroad audience matters. External identity adds redirect validation, nonce and state handling, and a provider relationship you must monitor. Service-to-service JWTs add key discovery and stale verifier risk. Write down which credential can reach which resource, who can mint it, how long it works, where it is stored, and how you stop it. That 5-line inventory is more useful than choosing an acronym from a framework dropdown. 3 concrete calls. 1. A first-party dashboard rendered by one web application. Use the identity provider you need, then establish an opaque, secure, cookie-backed session for the browser. 2. A mobile client calls several APIs. Issue short-lived access tokens with narrow audiences and scopes. Choose opaque or JWT based on whether those APIs truly need independent verification. 3. Customers sign in with Google or an enterprise provider. Use OpenID Connect for the login, then choose the session or access token model your own boundaries require. Notice that OIDC did not replace the session. It supplied the identity that began it. Here is the whole map. Authentication establishes identity. Authorization decides authority. A session says where login state lives. An access token is a credential for an API boundary. Opaque and JWT describe possible credential formats. OAuth delegates access. OpenID Connect adds external authentication. Choose each layer independently, keep lifetimes short where credentials travel, and prefer the simplest revocation story that meets the system's actual needs. The request can now cross the auth gate carrying a verified identity and a bounded authority. The next question is what that request is allowed to look like: URLs, methods, payloads, errors, and versioned promises. That is the API contract, the next stop in the request journey.